A well-constructed schedule provides a realistic model of when activities should occur. A good schedule is also flexible, so it can adapt easily to changes that arise during project execution. The schedule logic you create by defining the sequence of activities is a crucial component in a well-built schedule. Let's review best practices for sequencing activities. First, use finish-to-start dependencies between most activities. Second, avoid start-to-start links unless they are truly needed. In most cases, finish-to-finish links work well without the side effects that can arise with start-to-start. Start-to-finish links are rare and confusing. Avoid them unless they are really necessary. Third, apply lagged dependencies only to reflect passage of time. Do not use lag if a delay is due to work that must be performed. Fourth, avoid negative lag, or lead, because it implies that you know when the predecessor activity will finish. Instead, try using shorter tasks with finish-to-start links. Fifth, every activity, except for the first and last, should have at least one predecessor and one successor. That way, both the activities start and finish tie into the overall schedule. So delays that arise can propagate through the schedule. To help you follow this best practice, many project management tools offer a feature to search for activities without predecessors and successors. Activities that represent inputs or outputs to the schedule, such as delivery of a product from an external organization, might not have predecessors or successors. For these outliers, be sure to document why the dependencies are missing. Sixth, don't link summary tasks. A summary task is a summary of the activities that belong to it, so summary links aren't needed if you've linked activities correctly. In addition, summary task links make schedule logic hard to follow. Seventh, eliminate redundant links and circular links. Redundant links are links that perform the same duty as another link in the schedule. These redundant dependencies make schedule logic hard to follow and can lead to errors. For example, the link between task A and task C is redundant because task A is linked to task B, which is linked to task C, which already defines a link between A and C. A circular link is a link from one activity to another, which then links back to the first activity, which is logically impossible. For example, task B can't start until after task A is done. That makes the finish-to-start link from task B to task A impossible. Eighth, avoid applying date constraints to activities unless absolutely necessary. Constraints limit the schedule's flexibility and can introduce excessive slack, also called float, into the schedule. Must start on and must finish on are inflexible constraints, also known as hard constraints. The only time you should use these is when they are the only way to model when an activity will occur. For example, a public training class that is scheduled for specific days. Semi-flexible constraints, like start no later than or finish no earlier than, don't limit the schedule as much, but still should be applied with care. After you sequence activities, review your schedule using these guidelines and correct the schedule logic if necessary.